Okay, hello and welcome to our session. We are focusing on Java and AI from experiments to business implementations. I'm Anne Plessé with Azul. I'll be your host, and with me is Frank Delaporte. Frank, can you do a brief introduction of yourself?
Yeah, pleasure. Thanks for inviting me. I'm Frank Delporte, live in Belgium, doing Java development for a long time. Over 15 years, I've been doing Java development myself. And since 3 years, I've joined Azul as one of the tech writers. And I'm taking care of the documentation together with my colleagues and also some blogs and related stuff. And that's probably why you invited me, based on this one blog that we published recently. And actually, that was based on a webinar we did with Fujay,
Right.
the website for the Friends of OpenJDK, where we talked about, what are the Java libraries, and we will dive into all these. Another thing I did, as a very curious Java developer, I like to experiment. And I talked at FOSDEM last year about how you can chat with the docs of Azul as an experiment, which is using large language models, AI, the thing we're going to talk about today. And if people are interested in this project, they can find it as a JavaFX example application within the LangChain4j project, where we will talk about in a few moments.
Awesome. So we're going to do some technical deep dives today. So I think our audience is really looking forward to that. So my observation is that Java is becoming a top choice in AI workflows, specifically the beginning of the workflows, Frank, right? Where it's really the data prep, where you need, you're doing standardization, maybe data deduping, you're cleansing the data, or maybe even doing some feature engineering, right? So it's really important. But let's kind of take a step back here. A big picture, what are we going to talk about today when we discuss AI and Java?
Mm-hmm. Yeah, and that's really a good question. I had to search for this myself. What is the difference between AI and machine learning? And AI is actually the whole set around training a system to do human-like work. But that can involve two things. The traditional style of programming, if then do this. So we can just follow a playbook. And now the new thing, which is machine learning, and that's actually the topic we will be talking about today, is machine learning is how can we train a computer based on data to make decisions? What is in the data that it can learn about it? And that's the whole thing, what we see now. If most people now talk about AI, they are talking about chat. They are talking to a system and asking things. So there is an LLM model there, a large language model. And the model is actually the result of a machine learning process. You give it a bunch of data, and the computer is very good at finding patterns. And that's what happens. So let's start with a warning. A large language model is trained on a lot of data, a lot of text from websites, books, everywhere where they can find information, these companies use to build LLMs. And an LLM it predicts the most plausible next word after the previous ones. But they are pretty good at it. Being whether you want to write a love letter or some piece of complicated code, such a system will come up with something which looks okay.
Yep.
And then it's up to us, to the users, to really take a look at it. Is it good enough? Is it correct? Hallucinations, that's where they come from, indeed. So we probably all heard the story about some lawyer who asked ChatGPT, give me some past cases that I can use in my case, and it just came up with some stuff which didn't exist, but it looked reasonable because such a model knows the pattern. It knows how to write such a story. And that's what happens a lot with these large language models. But they train, I think almost every day there is a new large language model available. They train them on more and more data. In the latest models, they also included content from videos. So they are now also scraping YouTube and getting all this data. So the large language models you find online are generic models. A lot of data, and they try to fit all human knowledge into that one model. Some say we will never get there. Some say, yeah, it's right around the corner. We will see. But those systems, those machine learning systems, are not only there for text, they are there to recognize patterns. That's what they do. And I was looking for a nice example for this talk, and I came up with this awesome Lego machine learning. If there's one thing which is a pattern, then it's Lego bricks.
Yeah.
And if you look into this one page, the amount of projects where people have trained their own model based on Lego bricks is such a nice example. So you can build this Lego sorting machine, which with a camera checks each block and says, yeah, this is probably this kind of block and I have to sort it that way. This is a very nice example of how you can train a model. It's you give it a lot of data with a fixed structure and you tell, another nice example is just a bunch of pictures with cats and dogs.
Yeah.
So you tell these 10 pictures are cats, these 10 pictures are dogs, and the system will find the pattern. Yeah. What is a cat? What is a dog? And then you test it with some other pictures. And you'll probably need more than 10 pictures of each to get to correct training set. But that's actually what you need, a model. So what is AI? What will we talk about? It's not the generic AI. It is actually machine learning. How can we use machine learning in our applications? And then there are two things. First, you need a model. So you need to train a model. And that's what you're saying. You need a lot of data to train a model. Like, for instance, for camera recognition, if you want to find people or cars on moving video, then you need a lot of these pictures to say, this is a person, this is a car. So you need a lot of data to train your model. And once you have a model, then you can use it to interact with that model and ask it a solution for a given problem, like give me a love letter or create me an invoice or whatever. So you have this knowledge available there and you can do very generic tasks or a very specific task, like if you're in a factory and you're producing something along a conveyor belt, is find me the good ones and the bad ones and throw the bad ones from the belt. So you need a lot of pictures again of good products and bad products. So training your model, and then this is something which is very heavy for a system, which takes some time. But once you have the model, you can use it very fast to get results and use it in your application. So there are two different things. And luckily, again, in the Java community, which is the most important reason to do Java development is the community and the libraries. There are a lot of tools available there to do just that.
Talked about, so you talked a lot about, how to train the model. And then I think you moved into how to use the model, right? So maybe share some examples, like how does this work, with some online tools?
Yeah, so we all know, let me share my screen again. We all know ChatGPT. Yep. Now, ChatGPT is a user interface on top of a product created by OpenAI. So OpenAI is the company. They are building these LLMs, a lot of LLMs. If you go back to ChatGPT, you can select the free one or the plus one. The plus one is a more complex model. The same thing happens with Claude AI. It's also a chat interface. Again, here you see they have different models. Some are better in coding, some are better in text. So this is what most people nowadays consider as AI or machine learning. This is what they use to create text or have them help you in writing new code. So these are a few of the most known ones, and they are running in the cloud. So these are services provided by these companies. Now, what we also can do is run this locally. Like Olama is a program that you just download, you run it on your own system, and you have your own ChatGPT system running on your own system. And again, it has different models available. What is the advantage here? Yeah, if you use a lot of ChatGPT or Claude AI or one of the other competitors, yeah, you have to pay for it. Of course,
Right.
they're companies; they have to earn money. On the other hand, Olama, you can run it on your system. That brings the cost to you. If you just use it on your own machine to do software development, then yeah, you have your computer running, no problem. If you want to use it as a machine learning, an LLM system behind your backend services, then yeah, you need to deploy it in the cloud and you will need a server. So depending on how much use you have for these interfaces, you will need to move it either to a server somewhere in the cloud, use one of the existing providers, or yeah, just run it on your own computer. And that's what you can do with these systems.
Okay.
Now, what all these systems provide is APIs, and all Java developers know APIs. We use them to call a microservice, to generate an invoice again, the same example, to get data from another service, to show a Grafana dashboard, we get data from another service. And that's exactly the same what these chat interface providers do. And of course, they also have other services like image generation or image recognition or similar things. So you call an API. So you ask some API on a web address to generate with model GPT 4.1, write a one sentence bedtime story about a unicorn, and then you get a JSON reply back with under the soft glow of the moon and blah, blah, blah. So it's the kind of work we have been doing for centuries, I would say.
Yeah.
This is nothing new. It's just the kind of service that we are using is different than what we used. It's not just a database which stores data. It's some reasoning model which can do something more than just give us a number of records back. And the same documentation is available like if you run Olama on your own computer. It's just from your local host machine, so your own computer, that you ask, give me a chat answer to this question. And depending on the model you use, you will get a reply, correct or incorrect, hallucinating or not, but also based on what it's trained for, of course. So
that's a good baseline. That's a good baseline. I think you have one more point there, but I want to move into can you do this easily with Java?
Yeah.
Right. Maybe some other examples, right?
Yeah.
Specifically with Java.
Back to the browser, there are a lot of them. If I go back to the article, there people can find links to these different libraries.
Okay.
Let's go into one of them. So as I said before, you have two steps: train your model and use your model. And a few of these libraries have a specific use case, like for instance, deep nets. This is available either free for development, or depending on the use case, you have to pay for the more complex use cases. But what it actually does, it helps you to develop and deploy models and also train models. It also has a visual AI builder, so it has a lot of tools to make creating a model and using a model a lot easier. So this was part of the presentation we had in the webinar for Fujay, where it was explained that it was used based on existing a data set with fraud detection of Visa cards. So they used some existing data to find the fraudulent cases, and then they were able to use that model to find new fraud cases. So
wow.
that's what they trained with deep nets. So they trained the model on some existing data sets to have a very fast system to be able to detect fraudulent payments. That's deep nets. Another one is deep Java library. Again, it's also about using models, but also to build and train models. Okay. So if you want to train a model specific for your use case, find broken packages on my conveyor belt, or find fraudulent sales, or find whatever. If you have a set of data which has the good ones and the bad ones, or which has a pattern of these are the things you need to detect, then you can train your model with a library like
So
this.
yeah, deep Java library is a great way just to easily get started.
Yeah,
Is
to
what I'm
get
hearing.
started and
Yep.
create a model and use it specifically for your use case. And
Okay.
there is more. There is also deep learning for J. Again, a suite of tools for deploying and training deep learning models using the GVM. So people who are saying you need Python, I can already say, there are different alternatives. And actually, just like Python, they use some existing C++, C libraries or packages underneath, and then put some tools on top of it to make it easier for Java developers to use them. So those are three deep nets, deep Java library, and deep learning for J are three libraries, tool sets you can use for model training and also for using the models, but they are really oriented in the direction of the model. And then LangChain for J, that's the big name in the Java world for AI use. Actually, it originates from LangChain, which was a Python project. So it's inspired by that Python project, but within 1 year, this has gained a lot of traction, has done some amazing work. It's just a dependency you need in a Java project. And what is the goal of LangChain for J and also Spring AI, we'll show you an example of this one, is we are used to work, for instance, as Java developers with different databases, being a Postgres database, MariaDB, Oracle DB, whatever. But we don't want to write different code for each database. And that's what we can do with different Java libraries. Like, for instance, Spring Boot, you define the type of database in a property, but your code stays the same. And that's exactly the same thing what they want to do with these libraries. Make it as easy as possible to interact from your Java code with different services. So like here it says, I want to create an OpenAI chat model, but that's just chat model is a generic thing within this library. And this is the OpenAI version. So I have an API key. I paid for this service that I can use it. I want to use this model from OpenAI. I build it and then I can ask a question and I will get a reply. If I want to move tomorrow to the system by Anthropic, so Claude AI, I just need to change the model. And the rest of my code will stay the same. And that's exactly the same thing what Spring is doing. So Spring AI, Spring Boot has and Spring has some marvelous ways of doing this with databases. So you just have your entities and repositories. So this is all code. And in configuration, in properties, you say, my database, you have to connect to it with this string, and it's this type of database. This is the password and the login. And here happens the same thing. So you have to define your API key in a properties file.
Okay.
And then your chat client will not change. If you change this to another provider or Olama, if you want to run this on your local machine, you can do that and your code will not change. So it's very easy to try out different services. Where do I get the best answer for my use case? Which service should I use, or what is the cost, or will I run it locally? So you can very easily, with these libraries, do exactly the same things that a lot of people are doing nowadays with Python, but in Java, and just stay within your Java environment as we are used as Java developers.
Yeah, if we were to dig into Spring AI, I remember we were talking about this, I think the key thing there is it abstracts the interfaces to use various LLM and AI services with a unified approach, right? That's the key with Spring, right? Where LangChain4j could be something where at least in some of my due diligence I've done, is it's really helps build robust retrieval augmented generation or RAG applications. Right. So those are some of the use cases or difference. If I can just kind of summarize. Okay, cool.
And also further, so you can also upload an image and get a description back. On this image, I see this and this and this. So all this kind of
slick.
All these kind of use cases are available through these libraries because they know how to interact with different providers who provide this kind of services. So it's not only OpenAI and Anthropic, it's also Microsoft has tools like this, Google has tools like this. So there are different tools available. And with the same code, you can easily compare them, try them out, and see what gives you the best result.
Lots of toys.
Lots of toys.
So let's switch gears here. So final question here is, why should I consider Java versus Python? I know that's also, there's a little bit of friction out there, but I think there's a good answer. What's your point of view on that?
Because we all love Java. Is that a good answer?
That's true. We do.
No, there is no best language. There's the best language which fits in your team. That's definitely one. What is your team used to use? If you're in a Java team, then just using Java is the most logical choice. It fits with your CI/CD flow. It fits within your build tools. It fits within your IDE that you have already. It fits within all the knowledge you already have of building applications, testing applications, deploying applications. There's one thing I want to show you related to this. I know it's a bit controversial, but this is some study which was done a few years ago, and they compared exactly the same function, the same methods, and they compared them across programming languages. And then C is the standard. So to do something specific with C, it takes 1. If you do it with Java, it takes 2 times the same energy. So, Java needs a bit more energy, but we know from experience, if you have a Java system which runs for a longer time, which gets fully optimized and warmed up, that this factor goes down. We go very close to C and C++, in some cases even below them. But this is a very dangerous one, in my opinion. So a Python script with the same functionality uses more than 70 times the energy of the C. And it's not only energy, because this is the ecological cost. But if it takes more energy, it takes more time, it takes more resources. So at the end, it costs you a lot more money. So building Java applications, for whatever reason, so also for AI machine learning use cases, it also has a valid point if you look at it from energy and cost use. And we know, a few things I want to highlight. This is an Azul presentation, so we should also mention, of course, our own runtime, the Zing runtime.
Right.
We have, within our Zing, we have the C4 garbage collector, so the continuously current compacting collector, which is a very good garbage collector. It's inspired others to be copied. Which makes sure that your Java application is running at maximum speed the whole time, even when garbage collection is ongoing. And then for longer running applications with heavy load, we have our own just-in-time compiler, the Falcon compiler, which is capable of optimizing your Java bytecode into the most efficient native code for your use case. So again, this will take down this difference between C and Java, and definitely between Java and Python, make that a much better choice to run any Java-like application or AI-like application with Java. So if you are in a Java team, that means that you invested already a lot of time and effort and processes to build the right tools in the best possible time, have them deployed and tested in the best possible way. So if you can do the same with AI applications, then there are a lot of... I'm really amazed by how fast Spring AI and LangChain 4j were created.
Right.
I think I saw LangChain 4j the first time, it will be 2 years ago in October at Devox in Belgium. I was blown away by the presentation by Lise Raas, who is involved in the development of the library, where she in 1 hour showed 11 different applications. with an early version of LangChain 4j at that time.
Yeah.
And that's even how I reused her codes. Of course, I'm a developer. I
Yeah.
like to copy paste.
As well.
I use
Yeah.
I used her codes in my FOSDEM example with the JavaFX user interface to chat with docs. My conclusion is, if you're using LLMs, be careful. We have mentioned the hallucinations before. But we are at the point that you can create really amazing things.
Very quickly.
Also,
Very quickly.
yeah.
Yeah.
Also, be very careful if you make a chat system your salesperson or your support person, because there are some strange things which can happen there too. But anyhow, you can build amazing things, and we have the libraries to do that with Java. And I think that's a very important message to keep in mind, that maybe don't throw it in production yet, but try it out.
Yeah.
And see how we had Innovation Week recently at Azul. So I took my example of last year of FOSDEM and I just updated it to the current state, and you can do so much more. Like keeping the memory of the chat and using that, search for related content in existing docs and show it to link persons, not give them just an answer, but
Yeah.
if you want to learn more, check this website, check this page, go to that part of the page. So be prepared to include it in your product. And if it's a Java project, then yeah, we have everything available there to build and run it in a very performant, very fast way in existing applications or new ones.
Yeah, very good. No, very inspiring. So we'll leave it there. So Frank, thank you so much for this discussion. A lot of good information about specific tools and resources and how to. So if you're keen to learn more about some of the blogs and some of the stuff that Frank shared, we'll go ahead and show that. Just go ahead and Google that, or we can certainly punch out the links to that as a part of our session today. So, Frank, as always, I always learn so much from you. Thank you. And if you're interested in learning more from Frank, feel free to connect with him on LinkedIn. We always enjoy that here at Azul, like to keep the conversation going. And thank you so much for listening to our session today. Thank you.
Thank you.